In the first video, I explained the introduction to the pentophosphate pathway and described its products. In this video, I will explain how the oxidative branch, or stage 1 of the pentophosphate pathway operates. Again, here the goal is to produce NADPH from the oxidation of glucose 6-phosphate. So here's the first reaction. We can see that the reactant is glucose 6-phosphate, and if we look at this carbon number 1 here, we can see that when we form the product, the 6-phosphogluconodeltalactone, that it is oxidized. So that means that protons and electrons are lost. You can see the protons shown in blue and red right here. And those protons, as well as 2 electrons, are picked up by the NADP+ to form NADPH. So just in our first reaction, we've already formed a molecule of NADPH, which is the goal. The enzyme is glucose 6-phosphate dehydrogenase, and remember that the dehydrogenase enzymes catalyze redox reactions. In the second reaction, we're going to take the 6-phosphogluconodeltalactone and we're going to do a hydrolysis and open up the ring. So if we open up the ring, we get the straight chain or the Fischer form of the sugar, and we can see here that we have in fact oxidized the this carbon number 1 because we have a carboxylic acid instead of an aldehyde. In the third and final reaction of the oxidative branch, we are going to take the 6-phosphogluconate and we are going to perform an oxidative decarboxylation. We'll remove carbon number 1 as a CO2, and that brings the total number of carbons from 6 down to 5. This carbon here will be oxidized. Instead of being bound to an OH, we will oxidize it to a ketone. So protons and electrons again are lost, and they will be picked up by the NADP+ to form NADPH. And again, the enzyme, the dehydrogenase, reflects the fact that this is a redox reaction. So if we take those 3 reactions and add them up, we find out that what we've done is we've started with 1 molecule of glucose 6-phosphate. Our product is ribulose 5-phosphate, which is a 5-carbon sugar. That extra carbon is lost as CO2, which would be exhaled, and the NADP+ has picked up electrons and protons to form NADPH. So the stoichiometry of stage 1, the oxidative branch, is when you start out with 1 glucose 6-phosphate and you go through stage 1 one time, 2 NADPHs are the product. So that was a summary of the oxidative branch of the pentophosphate pathway. In the next video, I will show how the product of stage 1, the ribulose 5-phosphate, is transformed into other carbon intermediates in stages 2 and 3.